Close your eyes for a moment and imagine the last time you almost died. Maybe you don't have to imagine. Maybe you remember it perfectly. The car that ran the red light and missed your driver's side door by 18 inches. The step you caught yourself on at the top of a staircase. Your hand finding the railing at the exact instant your ankle turned. The fever that broke at 3 a.m. after climbing so high, your partner started looking up emergency room directions. The diagnosis that came back negative when you had already, in the quiet theatre of your own mind, begun rehearsing how you would tell people. Everyone has these moments, everyone alive, that is, by definition. And here is where something strange begins. Something that sounds at first like the setup to a magic trick or a late-night dorm room argument about philosophy. But it is neither. It is a consequence, a clean, logical, experimentally supported consequence of the most successful theory in the history of physics, a theory that has been tested to 12 decimal places of precision, a theory that powers the device you are listening to right now, a theory so accurate that if it were a measuring tape stretched from New York to Los Angeles, its predictions would be correct to within the width of a single human hair somewhere in Kansas. The theory is quantum mechanics, and the consequence is this: you may not be able to die, not in the poetic sense, not in the sense that your memory lives on, or your atoms get recycled, or your children carry your genes forward, in a far stranger sense, in the sense that the version of you capable of having any experience at all, capable of asking whether you survived, is always, by the very structure of reality, the version that survived, every time, without exception. The theory is called the many worlds interpretation. The logical endpoint we're walking toward tonight is called quantum immortality, and if you stay with me for the next 2.5 hours, I'm going to try to convince you that this is not science fiction dressed in a laboratory coat. It is a serious, defended, mathematically precise idea that has haunted physicists for 70 years, and that once you truly understand it, may change the way you think about the one thing you were certain was certain, your own ending. If these slow nighttime journeys help you think or drift or simply pass the dark hours, consider tapping that like and subscribe button. It costs nothing, and it helps these videos find others who need them. Now settle in. Let us begin. We need to start with a cat. You knew we would. But before we get to the cat, we need to understand why the cat was necessary in the first place. What problem was it trying to solve? What question was it trying to make unbearable? The year is 1935. The place is a cramped study in Oxford, England, where a 50-year-old Austrian physicist named Erwin Schrödinger is writing a letter. The letter is to Albert Einstein. The two men have been corresponding for years about a shared frustration, a shared horror really, about the direction quantum mechanics has taken since its founding. Because quantum mechanics by 1935 is already unambiguously successful. It predicts the behaviour of atoms with absurd precision. It explains why matter is stable, why the sun shines, why certain chemicals glow in certain colours. It is not optional. Every experiment confirms it. The math works. But the math says something that both Schrödinger and Einstein find impossible to accept. The math says that before you measure a particle, before you look at it, interact with it, force it to commit, it does not have a definite position. It does not have a definite momentum. It does not have a definite spin. It exists in what physicists call a superposition, a weighted sum of all the possibilities, all at once, each one as real as the others. Stop and feel the weight of that. Not, we don't know which position it's in. Not our instruments aren't precise enough to tell. The math says the particle genuinely has no single position. It is, in a precise mathematical sense, in all of them. Spread out across space like a wave. Blurred, indefinite. And then you measure it. And the instant you measure it, the wave collapses. The blur snaps into focus. The particle is here, at this exact location, with this exact momentum. It was nowhere in particular, and now it is somewhere specific. The measurement made it real. This is called the Copenhagen interpretation, and it was, and still is, the standard way of talking about quantum mechanics. The version taught in textbooks, the version Niels Bohr championed, the version that says the math works, so use the math, but don't ask what's really happening before the measurement. That question has no meaning. Schrödinger and Einstein could not accept this. not because they were traditionalists clinging to an outdated view of the world. They had helped build quantum mechanics. Schrödinger's equation, the central equation of quantum theory, bears his name. Einstein's work on the photoelectric effect proved that light comes in discrete packets and helped launch the whole enterprise. These were not outsiders throwing stones. These were architects looking at their own building and saying, something about the foundation is wrong. Their objection was simple. The Copenhagen interpretation draws a line between the quantum world and the everyday world. Small things, electrons, photons, atoms, obey quantum rules. They exist in superposition. They are blurred until measured, but large things, cats, chairs, planets, people, obey classical rules. They are always definite. They are always somewhere specific. But where, Schrödinger asked, is the line? If an electron can be in a superposition of two positions, what about a molecule? A molecule is just atoms stuck together, and atoms are just electrons and nuclei. If atoms obey quantum rules, why wouldn't molecules? And if molecules can be in superposition, what about a virus? A virus is just a complex molecule. What about a cell? A cell is just a community of molecules. What about a cat? A cat is just a community of cells. If the math is right, if superposition is real, then there is no line. There cannot be a line. The quantum rules apply all the way up. And that means large objects, objects you can see with your eyes and hold in your hands, must also be capable of existing in superposition. Which brings us to the cat. Schrödinger's thought experiment was never meant to be a genuine proposal. It was a reductio ad absurdum, a way of showing that the Copenhagen interpretation leads to conclusions so ridiculous that it must be wrong, or at least incomplete. The experiment went like this. Place a cat in a sealed steel box. Inside the box, set up a device. The device contains a tiny amount of radioactive material, so tiny that over the course of an hour there is exactly a 50% chance that one atom will decay. If an atom decays, it triggers a Geiger counter. The Geiger counter activates a relay. The relay releases a hammer. The hammer shatters a flask of hydrocyanic acid. The acid kills the cat. If no atom decays, nothing happens. The cat lives. Now seal the box. Wait 1 hour. Before you open the lid, according to the Copenhagen interpretation, the radioactive atom is in a superposition. It has both decayed and not decayed. Both possibilities are equally real. Neither has been chosen yet. But the atom is connected to the Geiger counter, which is connected to the hammer, which is connected to the flask, which is connected to the cat. The chain of causation is unbroken. If the atom is in superposition, so is the Geiger counter, so is the hammer, so is the flask, so is the cat. According to the math, Schrödinger argued, you must conclude that before you open the lid, the cat is in a superposition of alive and dead. Not secretly alive or secretly dead with our ignorance hiding the truth. Genuinely both. The cat's state is as blurred and indefinite as the electrons. Schrödinger intended this to be obviously absurd, a criticism, a way of showing that the Copenhagen interpretation cannot be the whole story, because cats cannot be simultaneously alive and dead. That is not how the world works. But here is what happened instead. Physicists shrugged. Maybe cats can be in superposition, they said. We just don't notice because the superposition collapses the instant anything observes it. The instant information about the cat's state leaks out into the environment. The cat is both alive and dead for the briefest of instants, and then reality chooses. This answer satisfied almost no one who thought about it carefully. It replaced one mystery with another. What counts as an observation? Who is the observer? Why does observation have any special role in physics at all? Bohr and Heisenberg tried to draw the line at consciousness, at the moment a human mind becomes aware. But that seemed even stranger. Was the cat itself not conscious enough? Did the radioactive atom hang in limbo until a human lifted the lid? The Copenhagen interpretation had no clean answers. It worked, in the sense that it gave correct predictions. But it papered over a conceptual hole so large you could fall through it forever. And so, for nearly 20 years, the problem festered. Textbooks taught the Copenhagen rules without examining them. Graduate students learned to shut up and calculate, a phrase that became an unofficial motto of quantum mechanics. The math works, so use the math. Don't ask what's really happening. That way lies philosophy, and philosophy doesn't publish papers. And then, in 1957, a graduate student at Princeton decided to ask anyway. Hugh Everett III was 26 years old, and he had a different idea. His idea was simple in structure and shattering in implication. What if the wave function never collapses at all? Let me say that again, because it is the foundation of everything that follows. What if the wave function, the mathematical object that describes all the blurred possibilities, all the positions and momenta and states superposed on top of each other, never collapses? What if nothing special happens when you measure something? What if the measurement itself just becomes part of the superposition? Here is what that means. When you open the box containing Schrödinger's cat, according to Everett, the cat does not stop being in superposition. Instead, you become entangled with the superposition. You, the observer, split. One version of you opens the box and sees a living cat. Another version of you opens the box and sees a dead cat. Both versions are equally real. Both exist. Both have experiences. Both remember opening the box. But they can never interact with each other again, because they have branched, become separate threads of reality, woven out of the same original moment but diverging forever after. This is the many worlds interpretation. Every quantum event that has multiple possible outcomes does not choose one outcome and discard the others. It does all of them. The universe splits, or rather, and this is important, the universe does not split into separate bubbles flying apart in space. It branches in a more abstract sense. The wave function develops structure. Different components of the wave function become orthogonal to each other, unable to interfere, unable to reunite. They become, for all practical purposes, separate worlds. Stop and feel the weight of that. Every time an electron passes through a double slit, the universe branches. Every time a radioactive atom either decays or does not decay, the universe branches. Every time any quantum system has multiple possibilities and something, anything, interacts with it, the universe branches. Not occasionally, not in special circumstances, constantly, right now, while you listen to these words. At every moment the branching is occurring. The number of branches is not in the billions. It is not in the trillions. It is not in the Googles or the Googleplexes. The number of branches is a number so large that language has no name for it, and human intuition has no grasp of it. If you tried to count to it, and you counted one branch per Planck second, the smallest meaningful interval of time physics allows, and you counted for the entire age of the universe, you would not have finished writing down the first digit of the exponent. Every possible outcome of every quantum event from the first moment of the Big Bang until right now exists, is real, has happened, is still happening. And if that is true, if the many worlds interpretation is not just a mathematical convenience, but a genuine description of reality, then something follows, something that concerns you directly. Let us return to your near-death experience, the car running the red light, the staircase fall you almost didn't catch, the fever, the diagnosis. Except now, let us describe it in the language of many worlds. When the car ran that red light, the timing depended on quantum events, the firing of neurons in the driver's brain, quantum processes, ultimately, the engine combustion that determined how fast he was going, quantum processes, your own heartbeat, your own braking, your own position on the road, all built on a foundation of quantum probabilities that could have gone differently. In the many worlds interpretation, they did go differently. Somewhere. In one branch, you stopped 6 inches earlier than you did. The car passed harmlessly behind you. You felt a rush of fear and gratitude and drove home with shaking hands. You're listening to this video now. In another branch, you stopped 6 inches later. The car hit your door. The window shattered. The steering column crushed your chest. You did not drive home. Both branches exist. Both are equally real. Both contain versions of you, or rather, both contained versions of you, until the branching occurred. After the branching, one version continued. The other version ended. But here is the question that haunted a physicist named Max Tegmark for years. The question that keeps anyone who truly understands many worlds awake at night. What did it feel like to be in the branch that ended? The answer, Tegmark eventually argued, is that it felt like nothing. Because there was no it to feel. The version of you that died did not experience death. That version's consciousness simply stopped. There was no moment of ending from the inside, no fade to black, no final thought. One moment, there was experience. The next moment, there was no experiencer to have a next moment. But the version of you that lived, the version whose neurons kept firing, whose heart kept beating, whose breath kept coming. That version did experience a next moment. That version is still having next moments. That version is you. And here is the thought that will not let go once you grasp it. From your subjective point of view, you have never experienced not surviving. You cannot experience not surviving. The only versions of you that have any experience at all are, by definition, the versions that continued. The dead branches are silent. They do not report. They do not remember. They do not feel. So when you look back on all the moments in your life that could have killed you, and there are more than you know, more than you can count, every moment threaded with quantum probabilities branching and branching and branching, you see only the branch that survived. Not because it was special, not because you were protected, but because the other branches contain no one to look back. This is called quantum immortality, and it is not a belief. It is not a religion. It is a logical consequence of taking the many worlds interpretation seriously. If the universe really branches, and if consciousness requires continuity, then the consciousness that asks, "Did I survive?" is always, always the consciousness that survived. Let that settle for a moment. Now I need to be careful here. I need to slow down and put some guardrails on the path before we walk further. Quantum immortality as a concept has been criticised, attacked, dismissed, and mocked by serious physicists for decades. Many, perhaps most, working physicists regard it as a philosophical curiosity at best, a misunderstanding of quantum mechanics at worst. They argue that Tegmark's reasoning contains hidden assumptions that may not hold. They argue that the concept of subjective experience is too slippery to build physics arguments on. They argue that the many worlds interpretation itself, while mathematically elegant, may not be the correct description of reality. These are not fringe objections. These are mainstream objections, and I want you to hold them in your mind as we continue, because this video is not going to claim that quantum immortality is proven. It is going to claim something more modest, that if you accept certain premises that many serious physicists do accept, then quantum immortality follows. And that alone makes it one of the most unsettling ideas in the history of human thought. We are going to spend the next 2 hours exploring those premises, testing them, pushing on them, trying to understand what would have to be true about the universe for quantum immortality to be real, and trying to understand what it would mean for you if it were. But first, we need to understand many worlds more deeply. We need to see why anyone believes it at all. We need to see what evidence supports it, what evidence could in principle rule it out, and why, despite the incredulous stares it provokes, a significant fraction of physicists think it might actually be true. Because here is the thing about many worlds. It was not invented to explain immortality. It was not invented to comfort anyone about death. It was invented to solve a technical problem in quantum mechanics. The same problem Schrödinger's cat was designed to expose, and it solves that problem beautifully, completely, without needing any special rules about observers or collapse or consciousness. The uncomfortable implications about immortality are, in a sense, a side effect, an unintended consequence, a bill that comes due once you accept the theory. And that is what makes this so unsettling. Nobody wanted quantum immortality to follow from the physics. It just does. Hugh Everett wrote his thesis in 1957. His advisor was John Archibald Wheeler, one of the giants of 20th century physics, the man who coined the term black hole. Wheeler initially supported Everett's work. He thought it was brilliant, original, a way of cutting through decades of muddle about measurement and observation. But Wheeler also knew it was dangerous. Not dangerous to human safety, dangerous to a career. The physics community in 1957 was not ready for many worlds. Niels Bohr was still alive, still the Pope of quantum mechanics, still defending the Copenhagen interpretation he had championed for 30 years. To publish a thesis claiming that the Copenhagen interpretation was wrong, that the wave function never collapses, that the universe splits into countless branches, that every possibility becomes real, was professional suicide. Wheeler tried to soften the thesis. He met with Bohr in Copenhagen, trying to build bridges, trying to find language that would make Everett's ideas palatable. Bohr was unimpressed. More than unimpressed, dismissive. He saw Everett's work as a philosophical distraction, a waste of time, a wrong turn. Everett defended his thesis. He got his PhD, and then he left physics forever. He took a job at the Pentagon, working on nuclear war strategy. He developed mathematical techniques for calculating optimal bombing patterns. He made money. He drank heavily. He became, by most accounts, bitter and withdrawn. He never published another physics paper. He told his wife he wanted to be cremated and have his ashes thrown in the trash. He died in 1982 at the age of 51 of a heart attack. His daughter, who struggled with mental illness for years, later took her own life. In her suicide note, she wrote that she was going to a parallel universe to be with her father. It is hard to tell this story without feeling its weight. The theory that offers a kind of immortality was invented by a man who gave up on physics, gave up on hope, and died young. The theory that says every possibility is real was developed by someone for whom the reality he inhabited was not enough. I do not know what to make of that. I'm not sure anyone does. But the theory survived him. In the years after Everett's thesis, a few physicists took notice. Bryce DeWitt, a theoretical physicist at the University of North Carolina, read Everett's work and became a convert. It was DeWitt who coined the term many worlds interpretation. It was DeWitt who wrote the popular articles and gave the public lectures that slowly brought Everett's ideas to a wider audience. DeWitt's first response to the theory, though, was the same as everyone's first response. It was the response you probably had a few minutes ago. I simply do not feel myself split, DeWitt wrote to Everett. And Everett wrote back, do you feel the earth move? This is the key move. This is the response that silences the intuitive objection. You do not feel the earth move because you are moving with it. Your reference frame is the earth's reference frame. Relative to yourself, you are stationary. The motion is undetectable from the inside, and you do not feel yourself split because after the split, each version of you is in a separate branch. Each version has continuous memories. Each version remembers being the original. Neither version experiences the moment of branching, because at the moment of branching, both versions are identical. They diverge only afterward, as the different quantum outcomes play out. It is not that you split into two people who feel like copies. It is that the you before the branch and the you after the branch are connected in the same way. The you of 1 second ago is connected to the you of right now. Continuity of experience, continuity of memory. No gap, no seam, no moment where you feel torn in half. The branching is, from the inside, invisible. And that is why many worlds is so hard to test. It makes exactly the same predictions as Copenhagen for any experiment you can perform. The only difference is what it says is really happening, whether the other branches exist or not. And since you can never access the other branches, never communicate with them, never detect them, the question of their existence seems almost metaphysical. Almost. But not quite. Because there are ways to test many worlds. They're just very, very difficult. And the most famous proposed test, the one that haunts everyone who thinks about this seriously, is the quantum suicide experiment. Max Tegmark is a Swedish-American cosmologist, currently a professor at MIT, known for his work on the multiverse, the mathematical structure of reality, and the future of artificial intelligence. He is cheerful, energetic, given to diagrams and analogies. He does not look like someone haunted by the implications of quantum mechanics. But in 1998, he published a paper that haunted everyone else. The paper was called The Interpretation of Quantum Mechanics, Many Worlds or Many Words, a title that already signalled Tegmark's sense of humour, but buried in that paper was a thought experiment so disturbing that physicists have been arguing about it ever since. The quantum suicide experiment. Here is how it works. Imagine you have a gun. Not a normal gun, a quantum gun. The gun is connected to a quantum random number generator. Every time you pull the trigger, the generator measures the spin of an electron. If the spin is up, the gun fires and you die. If the spin is down, the gun clicks harmlessly and you live. In the Copenhagen interpretation, this is simple. Each time you pull the trigger, there is a 50% chance you die and a 50% chance you live. Pull the trigger enough times and you will almost certainly die. But in the many worlds interpretation, something different happens. Each time you pull the trigger, the universe branches. In one branch, the spin is up, the gun fires, you die. In the other branch, the spin is down, the gun clicks, you live. Both branches are equally real, both exist. Now here is the key question. What do you experience? From a God's eye view, looking at all the branches, you see a tree of possibilities spreading out. In many of the branches you are dead. In a rapidly dwindling few, you are alive. After 10 pulls of the trigger, only one branch in 1,000 contains a living you. After 20 pulls, only one branch in 1,000,000. But you, the subjective experiencer, do not have a God's eye view. You have only your own view, and from your own view, you can only experience the branches where you are still alive. The branches where you died contain no experiencer to have an experience. So from your perspective, the gun clicks every time. Click, 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 click. No matter how many times you pull the trigger, you never experience the firing. You cannot, by the very structure of consciousness, experience the branch where you are dead. Take Mark's conclusion. If many worlds is true, the quantum suicide experiment would demonstrate it. To you, personally, subjectively, from the inside. You would pull the trigger 100 times and survive 100 times, 1,000 times and survive 1,000 times. The probability of this happening in a single world universe is so small it rounds to 0. But in a many worlds universe, it is guaranteed. There is only one problem. No one else would be impressed. From the outside, from the perspective of anyone watching you, the experiment looks completely different. They see the branch where the gun fired. They see you die. They mourn you, bury you, move on. In their branch, the branch they experience, many worlds predicts exactly the same 50-50 odds as Copenhagen. They have no evidence that you survived in some other branch. They have only a corpse. This is the nightmare at the heart of quantum immortality. It is a private revelation, a truth that can only be known from the inside, a proof that cannot be shared. You could become absolutely certain that many worlds is true, certain because you have survived 1,000 quantum coin flips that should have killed you, and no one else in your branch would believe you. They would see only luck, or delusion, or fraud, and you could never prove them wrong, because the proof is in the branches they cannot access. Tegmark has been very clear that he is not recommending anyone actually perform this experiment. The experiment would kill you in almost all branches. It would leave your family grieving in almost all branches. Only a vanishingly tiny fraction of branches would contain a triumphant survivor. And even in those branches, the survivor would be alone in their knowledge, unable to convince anyone else. This is not a recipe for happiness. This is not a recipe for enlightenment. This is a thought experiment designed to clarify what many worlds predicts, and what it predicts is, from a certain angle, a kind of hell, because the implications do not stop at quantum suicide. Think about what we have established so far. If many worlds is true, every near-death moment you have ever experienced was a branching point. In some branches, you died. In the branch you're in, the only branch you can ever be in, you survived. But you have been near death more times than you realize. Every second, millions of cosmic rays pass through your body. Most do nothing, but occasionally, rarely, one of them strikes a cell at just the wrong moment and begins a cascade that leads to cancer. Whether this happens depends on quantum events, the precise position of atoms, the exact timing of molecular collisions, the quantum probabilities that govern radiation and chemistry. In some branches, you developed cancer years ago. In some branches, you died young. In some branches, an aneurysm you never knew you had ruptured while you slept. In some branches, the anesthesia during surgery hit a bad reaction. In some branches, a drunk driver hit your car on a night you don't even remember driving. You are, right now, the version of you that has survived all of these. Not because you are special, not because you are lucky, but because the versions that did not survive are not here to wonder why. And if this reasoning is correct, if the subjective continuity of consciousness really does track only the surviving branches, then it never stops. You will never experience dying, no matter how old you get, no matter how sick, no matter how many close calls. Each time death should claim you, the universe branches. In most branches, you die. But in some branch, perhaps a vanishingly unlikely branch, perhaps a branch where quantum fluctuations did something absurd and improbable, you survive. And since you can only experience branches where you survive, you keep surviving forever. This is quantum immortality in its full, terrible form, not a guarantee of a good life, not a guarantee of health or happiness, just a guarantee that you will never reach the end, that there is always another branch, that somewhere in the infinite tree of possibilities a version of you continues, and that version is the version that asks, am I still here? The answer is always yes. Let this settle for a moment. We're going to spend much more time with this idea, testing it, challenging it, looking at what could break it. But right now, I just want you to sit with the shape of it. The many worlds interpretation was developed to solve a technical problem in quantum mechanics. It was developed to explain why experiments work, why the math is consistent, why we do not need mysterious collapse events or special roles for consciousness. It is, in some ways, the most elegant interpretation of quantum mechanics. The simplest, the most parsimonious. It adds nothing to the equations, it just takes them seriously. And when you take them seriously, you find that you're not one person living one life. You're an infinite branching tree of persons, spreading through configuration space, diverging at every quantum event, most of them dead, a few of them still alive, and all of them, the living ones, equally convinced they are the original, the real one, the one who matters. There is something vertiginous about this, something that resists being held in the mind for too long, and there is something else too, something almost like hope, or almost like dread, depending on who you are and what you fear. Because if quantum immortality is true, you're not walking toward an ending. You're walking through an endless corridor of doors, and every door you might have walked through where death waited on the other side, you didn't. You took the other door, the one that led here, to this moment, to this breath, and you will keep taking that door forever. The question we must now confront, the question the rest of this video will explore, is whether this is actually what the physics implies, whether the many worlds interpretation is likely to be true, whether the logic of quantum immortality holds up under scrutiny, and what it would mean for you, tonight, listening in the dark, if it does. We are not finished. We have not even truly begun. So far, we have only walked to the edge of the cliff and looked over. Now we need to climb down and see what is actually there. But first, we need to understand what evidence exists for many worlds, why anyone believes it at all, and what alternatives exist that might rescue us from its implications. That is where we are going next. The first thing to understand about evidence in quantum mechanics is that it is not like evidence in most of science. You cannot point a telescope at the universe and see it splitting. You cannot build a detector that catches a branch peeling away from our own. The branches, if they exist, are gone the moment they form. They carry on their own existence in their own configuration space, forever inaccessible to us, forever beyond any signal or any probe. This is not a bug in the many worlds interpretation. It is a feature. It is, in fact, a prediction. If the branches could interact after separation, if information could leak between them, the mathematics would not work. The experiments would not match. The whole framework would collapse. So the inaccessibility of the branches is not a weakness in the theory. It is what the theory requires. But this creates an obvious problem. If you cannot see the branches, if you cannot measure them, if you cannot detect them in any way, how can you possibly know they are there? The answer, and this is crucial, is that the evidence for many worlds is not direct. It is indirect. It comes from the success of quantum mechanics itself. Every experiment ever performed in a quantum laboratory is evidence for the equations of quantum mechanics, and the many worlds interpretation is simply what those equations say when you refuse to add anything extra to them, when you refuse to invoke collapse, when you refuse to put consciousness in a special role, when you just let the math be the physics. This is a strange kind of argument. It is not the kind of argument you're used to hearing in science. Usually a theory makes a unique prediction, and you test that prediction. And if the prediction comes true, the theory gains credibility. But many worlds does not make a unique prediction that differs from other interpretations of quantum mechanics. Every interpretation agrees on what the experiments will show. They only disagree on what is really happening behind the experiments, on what the reality is that produces those results. So the argument for many worlds is not, look, here is an experiment that proves it. The argument for many worlds is, look, here is the simplest explanation of why all the experiments work. Let me try to make this more concrete. When you perform a quantum experiment, say you send a photon toward a beam splitter, where it has a 50-50 chance of going left or going right, you can predict exactly what will happen. You can calculate the probability of each outcome. You can repeat the experiment thousands of times and watch the statistics match your calculations perfectly. Quantum mechanics works. It is arguably the most precisely tested theory in the history of science. But here is the thing, quantum mechanics does not tell you, at least not directly, what happens to the photon before you measure it. If you send a single photon at that beam splitter and do not look immediately, the equations say the photon is in a superposition. It went left and it went right. Both. At the same time, not metaphorically, not we don't know which way it went. The math explicitly describes a state in which both possibilities are real. Both are happening, both are part of the physical system. This is not an interpretation. This is what the Schrödinger equation says. And then you look. You check which detector fires, and only one detector fires. Only one outcome happens, the left one or the right one. Now, here is the question that has haunted physics for a century. What happened to the other outcome? One answer, the traditional answer, the one taught in most physics courses, is that the other outcome never really existed. The superposition was just a mathematical tool, a calculational device. When you measured the photon, something called collapse happened. The wave function, which had been describing both possibilities, suddenly jumped to describing only one. The other possibility vanished. It was never real. This is the Copenhagen interpretation, named after the city where Niels Bohr and Werner Heisenberg developed it in the 1920s. It is not a theory. It is more like a set of instructions. It tells you, use the math to make predictions, but don't ask what the math means. Don't ask what the photon is doing when you're not looking. Just calculate and measure. Calculate and measure. For decades, this worked. Physicists learned not to ask certain questions. They learned to say things like, the question of what happens between measurements is not well posed, or we can only talk about what we observe. And they did brilliant work, building lasers and transistors and nuclear reactors, all without needing to resolve the puzzle of what the wave function really meant. But some physicists could not stop asking. In 1957, a graduate student named Hugh Everett III, working at Princeton under the legendary John Wheeler, wrote a doctoral dissertation that changed everything, or would have changed everything if anyone had listened at the time. Everett's question was simple. What if we do not add collapse to the equations? What if we take the Schrödinger equation at face value? What if the wave function, the mathematical object that describes quantum systems, is not just a tool but the actual physical reality? If you do this, something strange happens. When you send the photon at the beam splitter, the wave function describes it going both left and right. When the photon hits the detectors, the wave function describes both detectors firing. When you look at the detectors, the wave function describes you seeing the left detector fire and also you seeing the right detector fire. Both versions of you exist. Both are real. Both are part of the universal wave function. And then these two versions of you, one who saw left, one who saw right, become entangled with different parts of the environment. Air molecules bounce differently off you in each version. Photons scatter differently from the room. The versions interact with their surroundings in ways that amplify the difference, that deepen it, that make it impossible for the two branches to interfere with each other ever again. This is decoherence. And decoherence does not make the other branch disappear. It just makes it inaccessible. It seals it off. It banishes it to a region of configuration space that cannot be reached from here, cannot send signals here, cannot influence anything here. But it is still there. This is many worlds. This is what the equations say if you take them literally. No collapse, no special role for measurement, no mystery about when or how the wave function suddenly jumps. Just the smooth, deterministic evolution of a wave function that happens to describe an incomprehensible number of branches, all equally real, all continuing forever, all containing versions of you who remember a continuous past and expect a continuous future. Everett did not live to see his interpretation vindicated. He left physics after his dissertation was met with indifference or hostility. He went into defence work, developed methods for analysing military operations, and drank himself to death at the age of 51. His family said he never spoke about quantum mechanics at home. He never knew that decades later his idea would be taken seriously by many of the most brilliant physicists in the world, that it would become, by some measures, the most popular interpretation among theoretical physicists, that entire research programs would be built on it, that people would stay up at night, unable to sleep, thinking about what his equations implied. But let us stay with the evidence. If many worlds and Copenhagen and all the other interpretations make the same predictions for every experiment, How can we possibly choose between them? The answer lies in a principle that has guided science since the beginning. All else being equal, prefer the simpler theory, the one that adds less machinery, the one that makes fewer arbitrary stipulations, the one that explains more with less. This is called Occam's razor, and by this measure many worlds has a real advantage. Copenhagen requires you to add collapse to the equations. It requires you to specify when collapse happens, which is not clear, and different versions of Copenhagen give different answers. Some say collapse happens when a measurement is made. But what counts as a measurement? Does it require a conscious observer? Does a camera count? Does a bacterium count? Does a Geiger counter count even if no one looks at it? These are not rhetorical questions. These are questions that Copenhagen has struggled to answer for a century. The interpretation essentially draws a line between the quantum world and the classical world, between the tiny systems that obey superposition and the large systems that have definite states, and it cannot quite say where that line is or why it is there. Many worlds does not draw this line. It does not need to. There is no collapse, so there is no question of when collapse happens. There is no special role for measurement, so there is no question of what counts as a measurement. There is just the wave function, evolving according to the Schrödinger equation, branching whenever interactions occur, never stopping, never collapsing, never making exceptions for any scale or any system. In this sense, many worlds is more parsimonious. It adds nothing to the mathematics, it just refuses to subtract from it. It takes the equations that work, that have been tested beyond any reasonable doubt, and it says, this is reality. All of it. Every term in the wave function. Every branch. Of course, there is a cost. The cost is that you have to accept the existence of an incomprehensible number of branches, an incomprehensible number of copies of yourself, an incomprehensible number of alternate histories, all equally real, all inaccessible. Some physicists find this cost too high. They prefer to add collapse, even though collapse is mysterious, even though no one knows how it works, even though it requires drawing arbitrary lines. They would rather have one universe with extra rules than infinite universes with no extra rules. This is a philosophical preference, not a scientific one. Both sides would agree on what any experiment will show. They just disagree on what is real. But there is a deeper reason to take many worlds seriously, a reason that goes beyond parsimony. It is the only interpretation that treats quantum mechanics as complete. Every other interpretation either adds something to quantum mechanics, collapse, hidden variables, observer-dependent reality, or treats quantum mechanics as incomplete, as needing some future theory to fill in the gaps. Many worlds says no. Quantum mechanics is complete. The wave function is everything. And when you take it seriously, you find that reality is far stranger and far larger than you ever imagined. But you do not need to wait for a better theory. You do not need to hope that someday someone will explain the mystery of measurement. The mystery dissolves when you realize that measurement is not special, that you are part of the wave function, that you branch just like everything else. Let this settle for a moment. We are not making a scientific claim here that many worlds is proven. No interpretation of quantum mechanics is proven. The interpretations are frameworks for understanding what the experiments mean, and the experiments do not choose between them. But we are making a claim that many worlds is taken seriously by a significant fraction of working physicists, that it is not fringe, that it is not science fiction, that it follows directly from the mathematics that has been tested to 12 decimal places in laboratory after laboratory for the past century. And we are making a claim that if many worlds is true, if the wave function really does describe all of reality, branching constantly forever, then the logic of quantum immortality follows. Let me trace that logic one more time, now that we understand the foundation better. You exist. You are a physical system made of atoms, embedded in the universe, described by the universal wave function. At every moment, quantum events occur in your body. Particles decay or do not decay. Neurons fire or do not fire. Molecules bind or do not bind. Each of these events, the ones that are genuinely quantum, genuinely uncertain, causes the wave function to branch. Most branches are very similar. The difference of one photon scattering left instead of right does not change your life. But some branches diverge dramatically. In some branches, a quantum fluctuation causes a cell to become cancerous. In others, it does not. In some branches, A cosmic ray triggers a mutation in your DNA. In others, it misses you entirely. In some branches, a thermal fluctuation causes a blood vessel to rupture in your brain. In others, the fluctuation goes the other way, and you live. All of these events are happening, all of the branches are real, and in every branch where you survive, there is a version of you that keeps experiencing life, keeps remembering the past, keeps expecting the future. Now here is the key insight. You, the you who is listening to this, the you who is conscious right now, or it can only be in a branch where you have survived, by definition. Because if you had not survived, you would not be here to ask whether you survived. This is not philosophy. This is logic. The same logic that explains why you find yourself on a planet with oxygen instead of a planet made of lava. The planets made of lava cannot support you. The branches where you died cannot support your consciousness. You are selected, not by any external force, but by the simple fact of being a question asker, into the branches where the answers are compatible with your existence. And this selection never stops. No matter how many times death should claim you, through accident, through disease, through old age, through anything at all, some branch exists where you survive. Perhaps the probability is tiny. Perhaps it requires absurd quantum coincidences. Perhaps you survive only because a million particles happen to fluctuate in exactly the right way at exactly the right moment. But if many worlds is true, that branch exists. It is as real as this one. And since you can only experience branches where you survive. This is the claim. This is what the mathematics of quantum mechanics implies. If you take it literally, if you refuse to add collapse, if you follow Hugh Everett's logic to its end. Now we need to ask, is this reasoning correct? Are there holes in it? Are there escape routes? Let me give you the strongest objection first. The objection is about identity. About whether the you in another branch is really you at all. Here is the problem. When the wave function branches, the two versions of you that emerge are not the same person. They are different people with different experiences, different futures, different fates. One of them dies, one of them lives. These are different people. So when we say you survive in the living branch, are we talking about you? Or are we talking about a copy of you? A different person who happens to share your memories up to the branch point? This is not a trivial objection. If the dying version of you is you, and the surviving version is someone else, then you die after all. Quantum immortality is just a comforting story about someone else living on. But let me push back on this. Think carefully about identity, about what makes you you. Are you the same person you were 10 years ago? You share some memories with that person. You share some continuity of experience. But your cells are different. Your thoughts are different. Your brain has changed in countless ways. Are you the same person you were 1 second ago? Even in that second, particles have moved, neurons have fired, memories have been encoded slightly differently. The person you were before reading this sentence no longer exists. That person was replaced, continuously, smoothly, by the person you are now. What is the difference between this continuous replacement and the branching that occurs in many worlds? In both cases, there is a version of you before and a version of you after. In both cases, the after version has memories of being the before version. In both cases, the continuity is real, but also illusory. Real in the sense that the memories persist, illusory in the sense that the underlying substrate changes. The many worlds interpretation does not create a new problem for identity. It inherits the same problem that already existed. You're not a static thing. You're a process, a pattern that persists through change, a river that keeps its name even as new water flows through it. And in many worlds, that pattern branches. One branch dies, one branch lives. Both branches think they are you. Both branches have equal claim to the memories and the identity and the name. But only one branch continues. Only one branch asks the question, did I survive? And the answer for that branch is always yes. This does not make death painless. The versions of you that die still die. In most branches you die. Perhaps you suffer. Perhaps you feel the moment of ending. Those branches are real. That suffering is real. But the branch that continues, the branch where you're still asking questions, still listening to words, still thinking thoughts, that branch also exists. And from the inside, from the only perspective you can ever have, that branch is the only branch that matters, because it is the only branch you experience. Let me offer another angle on this. Imagine you are about to undergo an operation. The surgeon tells you there is a 90% chance of success. In many worlds, this means that when the operation happens, the wave function will branch into many possibilities. In roughly 90% of the measure, the quantum weight, you survive. In roughly 10%, you do not. You go under anesthesia. You wake up in recovery. You survived. Now, here is the question. Did you get lucky? In the normal view of probability, yes. You beat the odds. 1 time out of 10, you would have died. But this time, you didn't. In many worlds, the answer is different. You didn't beat the odds. The odds were honoured exactly. 10% of the branches contain a version of you who died. 90% contain a version who lived. No luck was involved. Both outcomes happened. You just happened to be asking the question from a branch where you can ask questions. But here is the thing that matters for quantum immortality. This reasoning applies even when the odds are terrible. Imagine a different operation, one with a 90% chance of death. In many worlds, when the operation happens, 90% of the branches contain a dead you, 10% contain a living you. Both outcomes happen. But you, the you who wakes up in recovery, the you who asks, "Did I survive?" can only be in the 10%. And if the odds were 99% against you, then you wake up in the 1%. And if the odds were 99 to 199% against you, then you wake up in the 0.1%. The probability does not matter. The improbability does not matter. As long as some branch exists where you survive, even if that branch requires the most absurd, most statistically unlikely sequence of events imaginable, you wake up there, you wake up somewhere, and you ask, "Am I still here?" And the answer, in that branch, is yes. This is the core of the argument. This is what makes quantum immortality so difficult to dismiss, and so difficult to accept. It does not depend on anything mysterious. It does not require souls or afterlives or supernatural intervention. It follows from the mathematics of quantum mechanics, combined with the logic of self-location, combined with the bare fact that dead people do not ask questions. But we are not done testing it. We are not done looking for the cracks. There is a physicist named Max Tegmark who took this idea seriously enough to design a thought experiment around it. A thought experiment so disturbing that no ethical committee would ever allow it to be performed. A thought experiment that, if many worlds is true, would prove quantum immortality from the inside. Prove it to exactly one person, the person who performs the experiment. That thought experiment is called quantum suicide, and that is where we're going next. But before we go there, let me give you a moment. You have been walking with me through some of the strangest territory in physics. Territory where the familiar dissolves, where the solid ground of one life, one death, one ending gives way to an infinite branching forest of possibility. I want you to sit with that image for a moment. You are not a line. You are not a single path from birth to death. You are a tree that grows in every direction at once. A tree with countless branches, most of them ending in darkness, a few of them reaching on toward light. And the branch you are on, the branch where you are hearing these words, where you are breathing this breath, where you are alive and conscious and wondering, is not special because it is the only branch. It is special because it is the only branch you can be on. The only branch where you can ask, "Which branch am I on?" And the answer is always this one, the living one, the continuing one, the one where the story goes on. Max Tegmark is a Swedish-American cosmologist at MIT. He is known for his work on the cosmic microwave background, on the mathematical structure of reality, and for a certain kind of intellectual fearlessness that leads him into territory where most physicists prefer not to tread. In 1998, he published a paper that would become one of the most discussed and most uncomfortable thought experiments in the history of quantum mechanics. The paper was called The Interpretation of Quantum Mechanics, Many Worlds or Many Words. But the part that people remember, the part that keeps philosophers awake and makes physicists change the subject, was a single section describing an experiment that could, in principle, be performed by one person on themselves with results that would be absolutely conclusive, to them and only them. Tegmark called it quantum suicide. I want to walk you through this carefully because the details matter, the logic matters, and the implications, if you follow them all the way, will not let you go easily. Picture a room, a simple room, white walls, a single chair in the centre, bright overhead lights. In the chair sits a person. Let's call them the experimenter. In front of the experimenter is a device. The device contains three components: a quantum random number generator, a mechanism that reads the output of that generator, and a gun pointed at the experimenter's head. The quantum random number generator is the key. This is not a pseudo-random number generator, not an algorithm that merely simulates randomness. This is a device that exploits genuine quantum indeterminacy. Perhaps the spin of an electron, perhaps the polarization of a photon, perhaps the decay of a radioactive atom. Something where the outcome is not determined by any prior state of the universe. Something where, according to quantum mechanics, the result is fundamentally, irreducibly random until the measurement is made. The device works like this. Every second, it measures the quantum system. If the result is spin-up, or polarization horizontal, or decay detected, call it outcome A, the gun fires. If the result is spin down, or polarization vertical, or no decay detected, call it outcome B, the gun does not fire. The experimenter hears a click, nothing happens, and 1 second later, the process repeats. In the Copenhagen interpretation, each measurement has a 50% chance of each outcome. Each second, there is a 50-50 chance the gun fires. If the experimenter sits in the chair long enough, eventually the gun will fire. Eventually the experimenter will die. The probability of surviving 10 consecutive measurements is 1 in 1024. The probability of surviving 100 consecutive measurements is 1 in a number so large that writing it would take 30 digits. Given enough time, death is certain. The experiment is, in Copenhagen terms, simply an elaborate form of Russian roulette with precisely calibrated odds. But in many worlds, something different happens. At the first measurement, the universe branches. In half the branches, the result is A, the gun fires, the experimenter dies. In the other half, the result is B, the experimenter lives. Both outcomes happen. Both are equally real. 1 second later, the surviving branches branch again. Half of them now contain a dead experimenter, half contain a living one. Both outcomes happen. Both are equally real. After 10 seconds, 1 in 1024 branches contains an experimenter who has survived all 10 measurements. After 100 seconds, 1 in an unreachable number of branches contains an experimenter who has survived all 100 measurements. The branches where the experimenter died are real. The branches where the experimenter lived are real. Both sets exist in the quantum multiverse. But here is the crucial observation. Here is where the logic of quantum immortality returns. The experimenter, the conscious, experiencing, question-asking experimenter, can only find themselves in branches where they are alive. The dead branches contain dead experimenters. The dead experimenters do not experience anything. They do not wonder if they survived. They do not ask questions. They simply are not there, subjectively speaking. So from the experimenter's perspective, from the inside, what happens? Click, alive, click, alive, click, alive, 100 times, 1,000 times, 1,000,000 times. The experimenter keeps hearing clicks, the gun keeps not firing, the universe keeps branching, and the experimenter keeps finding themselves in the surviving branches, because those are the only branches where there is an experimenter to find. This is not luck. This is not beating the odds. This is what it means to be a conscious observer inside a branching universe. You cannot experience your own non-existence. You can only experience existence. And in a universe where all branches are real, there is always a branch, however thin, however improbable, however vanishingly rare, where you exist. Tegmark's thought experiment is disturbing precisely because it makes this logic impossible to ignore. In ordinary life, the branching is happening constantly, but it is diffuse. The quantum events that might kill you are buried in complex biological and physical processes. The connection between a single quantum measurement and your death is obscured by layer upon layer of classical approximation. But the quantum suicide experiment strips away all that complexity. It creates a direct, immediate, unambiguous link between a single quantum measurement and the experimenter's survival or death. It forces the question, if many worlds is true, what would it actually feel like to be inside this experiment? And the answer, as Tegmark worked out, is that it would feel like immortality. Not immortality in the sense of living forever in a single timeline. Not immortality in the sense of never aging or never getting sick. but immortality in the sense of never experiencing the moment of death, always being the version that survives, always waking up on the other side of the 50-50 chance, always hearing the click instead of the bang. Let that settle for a moment. Really picture it. You are in the chair. The device is in front of you. You know the odds. You know that in half the branches you're about to die. You know that in half the branches you're about to survive. You press the button to begin the experiment. Click. You are alive. You felt nothing. The coin came up in your favour. You wait 1 second. Click. Alive again. 2 in a row. Not so unusual. 1 in 4 people would get this far. Click, 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 click. 6 in a row now. 1 in 64. Starting to feel lucky. Click, 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 click. 10 in a row. 1 in 1024. The odds against this are starting to get serious. You should be dead by now, statistically speaking. But you are not. You are still sitting in the chair, still hearing clicks. Click, 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 click. 15 in a row. 1 in 32,768. This is not luck anymore. This is something else. Something is wrong with the universe, or something is very, very right with the theory. Click, click, click. 20 in a row. 1 in a million. You should absolutely, certainly, impossibly be dead by now. But you are not. You are hearing your 20th click. Your hands are shaking. Your heart is pounding. You are starting to believe. And here is the horrible thing. Here is the thing that makes quantum suicide a thought experiment and not an actual experiment. Here is the thing that trapped Tegmark's logic in the realm of philosophy instead of physics. You cannot prove it to anyone else. From the outside, from the perspective of any observer who is not you, the quantum suicide experiment proceeds exactly as Copenhagen predicts. They see you sit in the chair. They see the device activate. They see you hear a click, or they see your brain splattered against the wall, roughly half the time each. After a few trials, they see you dead. They note that the experiment confirms the 50-50 odds of quantum mechanics. They write it up and move on. They never see what you see. They never see the impossible string of survivals. They never see the evidence for many worlds that you, and only you, would observe. Because in their timeline, in their branch, you died. The experiment ended. The data came out normal. Quantum suicide is, in a certain sense, the loneliest possible experiment. It produces proof, real proof, undeniable proof, but only for one person, only for the person in the chair, only for the consciousness that cannot be ended by a finite number of gunshots. And that person cannot share their proof, cannot publish a paper, cannot convince the scientific community, because to everyone else they are dead. This is why no one has performed the experiment. This is why no one should perform the experiment, not because it would not work, but because its success would be invisible, and its failure would be death. But Tegmark's thought experiment was never meant to be performed. It was meant to illustrate, to clarify, to show what many worlds actually implies for the question of subjective experience, and what it implies is troubling at every level. Consider the experimenter who survives 100 consecutive measurements. From their perspective, they've just witnessed something miraculous, something that should happen roughly once in a number of trials that vastly exceeds the number of atoms in the observable universe. They have beaten odds that are, by any conventional understanding, impossible. But they have not beaten anything. They have not defied any law of physics. They have simply observed from the inside what it means for all branches to be real. They have experienced the selection effect that consciousness imposes on the multiverse. They have learned, in the most visceral way possible, that dead men ask no questions. And this experience, this impossible run of luck, this evidence for many worlds, it would change nothing outside their branch. In the vast majority of branches, they are dead. In the vast majority of branches, the experiment confirmed Copenhagen. The scientific consensus remains unchanged. The papers are written, the textbooks are printed, the experimenter is mourned and forgotten. But in that one branch, that thin, improbable, vanishingly rare branch, someone knows. Someone has proof. Someone has experienced quantum immortality from the inside, and they can never share it. There is something almost religious about this structure, a revelation that is real but unshareable, a truth that saves one person and leaves the rest of the world unchanged. A private apocalypse, a private rapture, experienced in total isolation. I want to sit with that isolation for a moment. I want you to feel its weight. Imagine being that experimenter. Imagine surviving 1,000 consecutive measurements. Imagine knowing, with a certainty that borders on mathematical proof, that every outcome happened, that you are only here because you cannot be elsewhere, that your survival is not luck but necessity. And imagine trying to tell someone. They would not believe you. Why would they? They live in a branch where quantum mechanics works exactly as advertised, where coins come up heads half the time, where guns fire when they are supposed to fire. They have no reason to believe your story. They have every reason to assume you are lying or deluded or simply mistaken about how many times the experiment ran. You would be alone with your knowledge, alone with your proof, alone with the truth of what you are, a consciousness that cannot experience its own end, a thread of experience winding through an infinite branching tree, always following the living paths, always avoiding the dead ones, and no one would ever know. This loneliness is built into the structure of many worlds. It is not an accident. It is a feature of what it means for observation to happen from the inside, for consciousness to be trapped on a single branch, even while all branches are real. But there is another troubling aspect to quantum suicide, one that Tegmark himself identified, and that has kept philosophers busy ever since. What if the mechanism is not instantaneous? In the pure thought experiment, the gun kills instantly. There is no suffering, no delay, no time between the firing and the end of consciousness. The experimenter is alive, then dead, with nothing in between. But real death is rarely so clean. Real death often involves damage, pain, degradation, a gradual narrowing of consciousness rather than an abrupt ending. And in many worlds, every version of the dying process that is physically possible actually happens. Picture the experimenter again, but this time the gun does not kill instantly. This time the bullet wounds but does not kill. In some branches the experimenter survives the wound but is horribly damaged. In some branches they survive but are paralysed. In some branches they survive but are in constant pain. If quantum immortality is true, if the experimenter cannot experience their own non-existence, then they survive. But they may survive in any of the possible configurations. They may survive as a damaged system rather than a healthy one. They may survive in agony rather than comfort. And the selection effect that keeps them alive does not care about quality of life. It cares only about the bare minimum of consciousness required to ask, "Am I still here?" This is sometimes called the quantum hell objection. If you cannot die, but you can be damaged, then you might persist in states that are worse than death. States where consciousness continues but flourishes not at all. States of indefinite suffering, extending across an infinite tree of branching possibilities. Tegmark addressed this concern somewhat. He noted that in most realistic scenarios, the decay of biological systems means that death becomes increasingly probable over time, that aging and entropy narrow the branches where survival is possible, that at some point, every physically possible configuration of your body is incompatible with consciousness, and the selection effect ceases to apply. But this is cold comfort. It means that quantum immortality is not eternal. It means that you do eventually fade, eventually cease, eventually reach a point where no branch contains a conscious version of you. But it also means that the path to that fading might be long and strange and painful in ways you cannot anticipate. We are in difficult territory now. We are asking questions that physics alone cannot answer. Questions about the nature of consciousness, about the boundaries of self, about what it means to survive. And there is one more question we need to ask before we can move forward. One more question that hides in the structure of quantum suicide and only becomes visible when you look at it from the right angle. What counts as you? In the thought experiment, we talk about the experimenter as if there is a single, well-defined entity that either survives or dies. But in many worlds, identity is not so simple. Each branch contains a version of the experimenter. Before the branching, there is one. After the branching, there are two, or more, depending on the number of possible outcomes. Are all these versions the same person? When the universe splits, and one version of you survives while another dies, which one is you? The surviving one, obviously, from the perspective of the surviving one. But the dying one was also you, up until the moment of divergence. The dying one had all your memories, all your thoughts, all your hopes and fears and plans. The dying one was every bit as much you as the surviving one. Many worlds does not privilege any branch. It does not say that the surviving branch is more real or more important, or more you than the dying branch. It says that both branches are equally real. Both outcomes happened. Both versions of you, the one who survived and the one who died, exist in the full quantum reality. From the outside, from the God's eye view that sees all branches at once, there is no quantum immortality. There is just branching. Some branches contain living experimenters, some contain dead ones. The experimenter entity, viewed as a whole, extends across all branches, living and dead alike. Quantum immortality is a first-person phenomenon. It is about what you can experience, not about what exists. It is about the selection effect that consciousness imposes on the multiverse, not about the structure of the multiverse itself. And this raises a strange question. If quantum immortality is true, but only from the inside, if it is about subjective experience rather than objective reality, then what does it mean to say it is true? Is something true if only one person can ever know it? Is something real if it cannot be observed from the outside? Is quantum immortality a fact about the universe, or a fact about the inside of your head? These are the questions that make philosophers drink. These are the questions that Tegmark's thought experiment was designed to surface, even if it cannot answer them. But let me offer you one way of thinking about it. One framing that might help you hold the whole picture in your mind at once. Think of the multiverse as a vast ocean. An ocean of possibility, stretching in every direction, containing every outcome of every quantum event that has ever happened or ever will happen. In this ocean, you are a swimmer, a small consciousness, making your way through the water. You cannot see the whole ocean. You can only see the water directly around you. You can only feel the currents that touch your skin. Your experience of the ocean is limited to your immediate surroundings, your local branch, the tiny portion of the vast whole that you can perceive. But the ocean is there. The whole ocean is there. Every wave, every depth, every distant shore you will never see. It exists whether you perceive it or not. It is real whether you experience it or not. Quantum immortality is not a claim about the ocean. It is a claim about swimming. It is a claim about what it feels like to move through the ocean when you are a particular kind of swimmer. A swimmer made of consciousness, a swimmer who cannot experience drowning, a swimmer who always finds themselves in water they can breathe. The ocean contains swimmers who drowned. The ocean is vast enough to hold every possibility. But you, the swimmer who is listening to these words, the swimmer who is breathing this breath, you are in the water you can breathe. Not because the universe favours you, not because you are special, but because you are asking the question, and drowned swimmers do not ask questions. I want to leave you with that image for a moment. The vast, dark ocean. The countless swimmers, most of them already drowned. The few who remain, paddling forward, not knowing how many have been lost, not knowing how thin the thread of survival has become. And you, somewhere in that ocean, still swimming, still breathing, still wondering if you are the only one left, or one of many, or something in between. The ocean does not answer. The ocean does not care. The ocean simply is, in all its terrible and beautiful vastness. But you are still swimming, and as long as you are swimming, you are still here. Now I want to take you somewhere uncomfortable, somewhere the thought experiment has been leading us all along, even if you did not notice the current pulling you there. Because Tegmark's quantum suicide, with its rotating gun and its spin measurements, is a laboratory abstraction, a philosopher's toy, a clean room where death comes instantly and the mechanism is perfectly quantum. Real life is messier than that. Real death is messier than that. And if quantum immortality is true, if you, the subjective experiencer, always find yourself in a branch where you survived, then what happens when the survival is not clean? What happens when the branch that keeps you alive is not the branch you would have chosen? Let me paint you a picture, a different kind of picture than the one we have been looking at. You are driving on a highway, late at night, let us say. The road is empty, the sky is dark, your attention has drifted the way attention does when you have been driving for hours, and then there is a truck in your lane coming toward you, headlights blinding. You have perhaps a second to react, perhaps less. In the Copenhagen interpretation, what happens next is simple. Either you swerve in time or you do not. Either you live or you die. One outcome becomes real, the others vanish, the universe moves on. In the many worlds interpretation, Every possible outcome happens. In some branches you swerve successfully and drive on, heart pounding, hands shaking, suddenly very awake. In some branches you swerve too late and the collision is total, and you're gone before you know what happened. Instant. Painless. Over. But here is where it gets complicated. Because between the clean survival and the instant death, there are other branches. So many other branches. There is a branch where you swerve but clip the truck's bumper, where your car spins, rolls, comes to rest in a ditch, where you wake up in a hospital 3 days later with a broken spine, where you spend the next 40 years in a wheelchair, alive but changed, surviving but diminished. There is a branch where the impact damages your brain, where you wake up but you're not quite you anymore, where the memories are foggy, the personality altered, the sharp mind you were so proud of now working at half speed, struggling with words it used to wield effortlessly. There is a branch where you survive but your passenger does not, where you walk away from the wreck and have to live with that, have to carry that, have to wake up every morning for the rest of your life remembering the sound the impact made and knowing you were the one who lived. If quantum immortality is true, if consciousness always finds itself in a surviving branch, then which branch do you end up in? The answer, if you follow the logic strictly, is troubling. You end up in any branch where you are still conscious, any branch where the subjective thread of experience continues, any branch where there is still a you asking the question. And that means the branches where you survive but suffer, the branches where survival is a curse rather than a gift. Those branches count. Those branches are just as valid as the clean survivals. Those branches might, in some scenarios, be more likely than the clean survivals, because there are more ways to be damaged than to be intact, more ways to be diminished than to be whole. Stop and feel the weight of that for a moment. If quantum immortality is true, it does not promise you a good life. It does not promise you health, or happiness, or peace. It only promises you experience. It only promises that the thread of consciousness continues. However frayed, however thin, however difficult to call a life, you cannot experience your own death. But you can experience everything leading up to it. You can experience the slow decline, the fading faculties, the body that fails by degrees. You can experience surviving in a state you would never have chosen, trapped in a branch where the kindest outcome, the instant ending, was somehow always just out of reach. This is the dark corollary to quantum immortality, the shadow that falls across the whole idea when you look at it honestly. The philosopher David Lewis, one of the most rigorous thinkers ever to take the many worlds interpretation seriously, wrote about this before his death in 2001. He called it the problem of quantum torture. If you cannot experience your own death, but you can experience arbitrarily long periods of suffering leading up to it, then the subjective path through the multiverse might be nightmarish in a way that mere mortality is not. Mortality offers an exit, a final door you cannot see yourself walking through, but a door nonetheless. Every experience ends eventually. Every suffering has a terminus. But if quantum immortality is true, and if it applies even in the damaged branches, even in the diminished states, even in the bodies that have forgotten how to die, then where is the exit? When does it stop? Is there a you somewhere, in some far branch, still conscious after 1 billion years, still experiencing, still unable to find the door that will not open for you? I want to be careful here. I want to be honest with you about what we know and do not know. We do not know if quantum immortality is true. We do not even know if the many worlds interpretation is true, though the physics points strongly in that direction. And if quantum immortality is true, we do not know how it interacts with gradual decline, with fragmented consciousness, with states of awareness so diminished that it is unclear whether they count as experience at all. Maybe there is a threshold. Maybe consciousness is not a continuous thing that can persist through arbitrary damage, but a pattern that requires certain conditions to exist at all. Maybe when the brain deteriorates past a certain point, when the quantum correlations that might underpin experience finally break down, the thread snaps cleanly, and you are released. We do not know. Nobody knows. But the thought experiment demands that we confront the question, that we sit with the possibility, that we ask ourselves what we would want if the choice were somehow ours to make. A single death you cannot experience followed by nothing, or infinite survival, with no guarantee about the quality of that survival, no promise about the shape of the branches you will find yourself in. The ocean is vast, the swimmers are many. and not all of them are swimming towards shores they would want to reach. Let me pull back for a moment. Let me give you some air before we go deeper, because I have been leading you down a dark path, and I want to acknowledge that darkness before we continue. I want to admit that this is not easy territory, that the ideas we're exploring here, the implications we're tracing, they brush up against things that matter, things that are not abstract, things that might be waiting for you, for me, for everyone we love. Philosophy is sometimes accused of being a parlour game, a way for clever people to amuse themselves with puzzles that have no bearing on real life. And sometimes that accusation is fair, but not here, not with these questions. What happens when you die is not an academic matter. It is the most urgent question a conscious being can ask. It is the question that sits at the bottom of every religion, every mythology, every late-night conversation between friends who have had too much to drink and not enough answers. It is the question you will face whether you want to or not. The question that cannot be deferred indefinitely. The question that is coming for you. And here we are in the early decades of the 21st century, and the best physics we have, the most successful scientific theory ever constructed, the framework that has never failed a single experimental test. That physics is telling us something about this question. Not everything, not nearly enough, but something. It is telling us that reality is larger than we thought, that the universe, or the multiverse if you prefer, contains more than we can see, that every quantum event, every moment of superposition that resolves into an outcome, might not be a selection at all but a branching, a splitting, a multiplication of everything that exists. And if that is true, if the many worlds interpretation is a genuine description of what is actually happening, rather than just a mathematical convenience, then your death is stranger than you ever imagined, because the you who dies is real. The you who dies exists in the full quantum reality. But you, the you who is listening, the you who is asking, you are necessarily in a branch where you survived. You are the swimmer who did not drown, selected out of all the swimmers by the simple fact that drowned swimmers cannot ask questions. Is that comforting? Is that terrifying? Is it both at once, a kind of cosmic vertigo that does not fit cleanly into any emotional category? I suspect it is different for everyone. I suspect some of you are finding this reassuring in a strange way, finding a kind of peace in the idea that the thread of experience cannot be cut, that the subjective story always continues even if the character changes. And I suspect others are finding it horrifying, finding the idea of infinite survival more frightening than oblivion, preferring a clean ending to an endless branching into unknown territory. Both responses are valid. Both are honest reactions to an honest confrontation with the implications of quantum mechanics. The universe does not adjust itself to be comfortable. It does not calibrate its structure to our preferences. It simply is what it is, and we are here to witness it, whether we like what we see or not. But I want to offer you one more piece of the picture before we move on. One more thread to weave into this impossible tapestry. Because quantum immortality, even if true, is not the whole story. It is not the only thing quantum mechanics has to say about consciousness, about identity, about what it means to be you. There is another implication, a quieter one, an implication that sits beneath the branching and the survival and the endless multiplication of possibilities. It has to do with what you are, not what happens to you, not which branches you find yourself in, but what kind of entity you are in the first place. What kind of thing is doing the experiencing? What kind of pattern is tracing these paths through the quantum ocean? Let me ask you a question that seems simple, but is not. Are you the same person you were 10 years ago? I do not mean do you have the same name, the same body, the same social security number. I mean, are you, the conscious experiencer, the same continuous entity that was conscious 10 years ago? Is there a thread running through time that connects the you of then to the you of now? Or are you something else? A pattern that persists, a process that continues, but not a thing that remains identical through change? This is an old question. Philosophers have been arguing about it for centuries, long before anyone knew about quantum mechanics. The ship of Theseus, the puzzle of personal identity, the debates about what makes someone the same person over time, these are ancient problems. But quantum mechanics adds something new, something that was not available to the ancient philosophers, something that changes the shape of the question. In classical physics, in the world of billiard balls and clockwork mechanisms that Newton described, Identity seems straightforward. Objects persist through time. A rock is the same rock tomorrow that it was today. The atoms might rearrange, the surface might weather, but there is a continuous physical thing that we can point to and say, that is the rock. In quantum mechanics, this kind of identity becomes slippery. Consider an electron. 2 electrons, in fact. Electron A and electron B. They are in different places, doing different things. They seem like 2 distinct objects. But here is the strange truth. There is no such thing as electron A and electron B. There are not 2 electrons with individual identities. There are 2 instances of electronness, 2 locations where the electron field is excited in a particular way. But if you swap them, if electron A goes where electron B was and vice versa, the universe does not change at all. Not changes in a way we cannot measure. Does not change, period. The swap is not even a meaningful operation. The electrons do not have identities to swap. This is called the indistinguishability of identical particles, and it is not a philosophical quibble. It is a measurable fact. It has experimental consequences. The way quantum statistics works, the way bosons behave versus fermions, the reason lasers are possible, the reason matter does not collapse into a single point, all of it depends on this strange truth. Identical particles are not just similar. They are, in a deep sense, the same thing manifesting in multiple places. What does this have to do with you? You are made of particles. Electrons, quarks, gluons, photons, the whole zoo of fundamental entities that quantum field theory describes, and every one of those particles is indistinguishable from every other particle of the same type. The electrons in your brain are the same electrons as the electrons in a star a billion light years away. Not similar electrons. The same electrons in the sense that there is no property that distinguishes them, no hidden serial number that marks one as different from another. Your body, your brain, your consciousness, whatever it is a pattern made of these indistinguishable components. A pattern that persists through time even as the components cycle in and out. The atoms you are made of today are not the atoms you were made of 7 years ago. They have been replaced, recycled, scattered to the wind and rebuilt from food and air and water. But the pattern continues. The shape persists. The you that is listening to these words is made of different stuff than the you that started listening, but it feels like the same you. Now combine this with branching. In the many worlds interpretation, you are not one pattern. You are many patterns, a vast tree of patterns, branching and splitting with every quantum event, diverging into different futures, different experiences, different versions of yourself. And those different versions, the you who survived and the you who died, the you who turned left and the you who turned right, the you who married and the you who stayed single, they are all made of the same indistinguishable particles. They are all instances of the same fundamental stuff, arranged in different patterns. They are all, in a sense, the same thing. This is where the philosophy gets genuinely strange. Stranger than quantum suicide, stranger than immortality, stranger than branching universes. Because if identity is pattern, and if patterns branch, and if the components are indistinguishable, then what is the self? What is the continuous thing that seems to persist through time? What is the I that is asking the question? One possible answer, an answer that some philosophers take seriously, is that the self is an illusion, that there is no continuous entity moving through time and across branches, that there is only experience, only moments of consciousness, only snapshots of pattern that seem connected, but are not fundamentally unified in the way we intuitively believe. On this view, you are not immortal because there is no you to be immortal. The thread of experience is not continuous because there is no thread. There are only the beads, the individual moments, each one complete in itself, each one giving rise to memories of the others, but not actually connected to them in any deep metaphysical sense. This might sound like a defeat. Like quantum mechanics has taken away even the modest immortality it seemed to offer. But look at it from another angle. If the self is a pattern, and if patterns branch, and if every branch is equally real, then you're not one swimmer in the ocean. You are the ocean itself, or at least a significant portion of it. You are every branch, every outcome, every possibility. You are the you who lived, and the you who died, and the you who suffered, and the you who thrived. You are all of them at once, not sequentially, but simultaneously, not in time, but across branches. The subjective experience, the feeling of being one continuous self moving through one continuous story, that is the illusion. The reality is vaster. The reality is that you are spread across the multiverse like light through a prism, separated into components that seem distinct but are all part of the same beam. I am not asking you to believe this. I am not claiming it is true. I am showing you what the physics implies, if you take it seriously, if you follow the logic where it leads, if you refuse to stop at the comfortable halfway points. The many worlds interpretation does not just change what happens when you die. It changes what you are. It reframes the self as a branching structure rather than a linear thread. It dissolves the boundaries between the you who survived and the you who died, revealing them as aspects of a single larger pattern, a single quantum system, a single entity that cannot be fully grasped from any one branch's perspective. The you who is listening cannot experience its own death. That much seems to follow from the physics. But the you who is listening is not the whole story. It is one strand of a vast web, one voice in a chorus, one swimmer in an ocean full of swimmers who all share the same name. Let that image settle in your mind for a moment. The web of branching selves, the chorus of your own voice echoing across possibilities, the ocean of swimmers, some drowning, some thriving, all of them you. And now let me ask you the question that has been lurking beneath the surface of everything we have discussed tonight. If this is what you are, a branching pattern, a multiplying self, an entity that spreads across the multiverse with every quantum event, then what does it mean to care about the future? What does it mean to make choices? What does it mean to hope that things go well rather than badly? Because in the many worlds interpretation, things go well and badly. Both. Always. Every outcome happens somewhere. Every choice leads to every possible consequence. The branch where you make the right decision, and the branch where you make the wrong one. Both of them are real. Both of them contain a version of you. Both of them are part of the larger pattern that you are. Does that mean choice is meaningless? Does that mean nothing matters, since every possibility is realized anyway? This is the question that keeps philosophers up at night. This is the question that even the physicists who accept the many worlds interpretation often struggle to answer. Because it feels like it should undermine meaning. It feels like it should make everything pointless. But I want to suggest that it does not. I want to suggest that the opposite might be true. Because even if every outcome happens somewhere, you, the specific you reading these words, the specific branch you find yourself in, you only experience one path. Your choices determine which branch you find yourself in. Not which branches exist, they all exist, but which branch holds your subjective experience. And that matters. That is the only thing that can matter, from the inside, from the perspective of a conscious being navigating the multiverse. You cannot control what happens in other branches. You cannot save the versions of yourself who made worse choices, who ended up in darker corners of the possibility space. But you can determine where your thread of experience goes. You can choose the branches you find yourself in. The ocean is vast. The swimmers are many. Most of them are beyond your reach, beyond your influence, beyond anything you can do or know. But you can swim. You can choose your direction. You can aim for the light on the water, and that direction matters more than you might think, even in a universe where every direction is taken. Let me show you why. Consider a simple choice. You're standing at a crossroads, quite literally, two paths diverging in a wood. One leads toward a clearing where sunlight filters through the leaves. The other descends into shadow, toward a ravine you cannot see the bottom of. In the classical picture, you make your choice. You take one path, and the other possibility vanishes forever, unrealized. A ghost of what might have been. In the many worlds picture, you take both paths. Two branches of you walk forward into two different futures. Both are real. Both contain a conscious observer who remembers standing at that crossroads, who remembers making what felt like a choice. So does choice disappear? Does the decision become meaningless because both outcomes happen anyway? Here is where the logic gets subtle, and where I think many critics of many worlds go wrong. Because even though both branches exist, even though both versions of you are equally real, there is still something that determines which branch any given observer finds themselves in. And that something is the choice itself. The version of you who walks toward the light is the version of you who chose to walk toward the light. The version who descends into shadow is the version who chose to descend. The choice does not determine whether the other branch exists. It does not, cannot. But it determines which branch you inhabit, which thread of experience you ride, which future becomes yours. Think of it this way. Imagine you're about to flip a coin to decide something important. Heads, you take the job across the country. Tails, you stay where you are. In many worlds, both outcomes happen. There is a branch where you move, a branch where you stay. But here is the thing. In this case, the coin determines which branch you find yourself in. The quantum randomness at the heart of the coin flip, the thermal fluctuations in the metal, the interactions of countless particles, all of these create a genuinely indeterminate moment, a branching event, and you, the conscious observer, cannot know in advance which branch you will experience after the flip. But now imagine you do not flip the coin. Imagine you simply choose. You weigh the options, you consider your desires and fears, you examine the evidence, and you make a decision. In many worlds, both branches still exist. The one where you chose to move, the one where you chose to stay. But the branching structure is different now. The branch you find yourself in is not determined by random quantum events. It is determined by the specific pattern of neural activity in your brain, by the thoughts and memories and preferences that make you who you are. And that pattern, that self, is something you have some influence over. You can think more carefully. You can gather more information. You can cultivate certain values rather than others. You can shape the decision-making process that determines which branch you find yourself in. This is not freedom in the classical sense, not the ability to change which branches exist. That is forever beyond you. But it is something that might matter just as much. Call it navigational freedom. Call it branch selection. Call it the ability to choose your own path through an infinite garden of forking paths. The garden is not yours to redesign. But where you walk within it, that is still up to you. Let that settle for a moment. Because I think this distinction is crucial. I think it is the key to understanding how meaning survives in a branching universe. The many worlds interpretation does not abolish choice. It transforms choice. It shifts choice from being about creating possibilities to being about selecting which possibility you experience. And from the inside, from the perspective of a conscious being who can only ever experience one branch at a time, that selection is everything. It is the only game in town, the only kind of agency available to a creature navigating an Everettian multiverse. Now let me take this one step further, because if choice matters in this way, if it determines which branch you find yourself in, then suddenly the stakes of ordinary decisions become very strange indeed. Consider a choice that has nothing to do with quantum mechanics at its surface. You're deciding whether to eat a healthy breakfast or to skip it and grab coffee. A trivial choice, meaningless in any cosmic sense. But follow the branching logic. In some branches, you eat the healthy breakfast. In others, you skip it. Now, fast forward 20 years. In some branches, the accumulated weight of those tiny daily choices, breakfast, exercise, sleep, stress, has led to a healthier body, a body more resistant to disease, a body that survives the heart attack that kills you at 60 in other branches. The many worlds interpretation does not just branch at dramatic quantum events. It branches constantly, continuously, at every interaction of every particle in your body, in your brain, in the world around you. And all of those branches add up. All of those branches contribute to a pattern. The version of you who makes better choices, who tilts the odds ever so slightly in favour of survival and flourishing, is the version of you who will still be around to reflect on those choices later. The version who makes worse choices, who ignores the small daily decisions, who treats the present as if it has no connection to the future, that version still exists, still branches, still experiences the consequences. But the consequences are different, the branches diverge, and what felt like a trivial choice becomes, in the aggregate, across billions of branching events, a navigation of the multiverse. I am not saying that eating breakfast will save your life. I am not making a health claim dressed up in physics. I am pointing at something deeper. I am pointing at the way that ordinary causation, the way that actions have consequences, takes on a new colouring in the many worlds interpretation. Every choice is a navigation. Every action steers you towards certain branches and away from others. not by eliminating possibilities, but by determining which possibilities you experience. And now we come to the strangest part of all. Remember what we established earlier. Remember the argument about immortality. If you cannot experience your own death, if the subjective thread of consciousness always continues in the branches where you survive, then what does that imply about these navigational choices? It implies something remarkable and unsettling. It implies that the choices you make do not just affect whether you live or die. Because in some sense, from your subjective perspective, you always live. But those choices do affect how you live, which branches of survival you find yourself in. Whether the version of you that survives is thriving or suffering, healthy or broken, fulfilled or empty. Let me put this as starkly as I can. If the quantum suicide argument is correct, you will never experience your own death, but you will experience everything that happens before death. You will experience aging. You will experience illness. You will experience the consequences of every choice you made along the way. And in the branches where those choices were poor, where you neglected your health, where you courted unnecessary risks, where you failed to prepare for the future, in those branches, the version of you that survives may find itself surviving in conditions you would never have chosen. Surviving, yes, but surviving badly, surviving in pain, surviving in regret, surviving as a diminished fragment of what you might have been. Stop and feel the weight of that. Because this is where the quantum immortality argument reveals its teeth. It is not a promise of bliss. It is not a guarantee that consciousness leads to paradise. It is a statement about the structure of experience in a branching universe. You will always experience some continuation. But that continuation could be anything. Any branch where survival is possible, no matter how narrow, no matter how bleak, you will experience that branch if all other branches have terminated. The many worlds interpretation does not care about your comfort. It does not care about your quality of life. It only cares about the mathematics of survival and observation. Imagine a car crash, a violent collision at high speed. In some branches, you die instantly, unconscious before you can even register what happened. In other branches, you survive but with catastrophic injuries, unable to move, unable to communicate, trapped in a body that barely functions, in a mind that can barely think, but still, somehow, conscious, still experiencing, still observing. If the quantum suicide argument is correct, those are the branches you will find yourself in. Not the branches of easy death, not the branches of painless oblivion, the branches of continued experience, whatever form that experience takes. This is not a pleasant thought. This is not the kind of immortality that religions promise. This is something colder, stranger, more mechanical. Survival without salvation, continuation without comfort. The mathematics of consciousness in a universe that keeps branching, keeps splitting, keeps generating observers in every possible corner of possibility space. Now, I want to be clear about something. This is not proven. This is not established fact. This is an implication, a logical consequence of taking certain physical theories seriously. The many worlds interpretation itself remains controversial. The connection to consciousness remains deeply unclear. The quantum suicide argument depends on assumptions that many physicists would reject. But if you accept the premises, if you follow the logic, if you take seriously the idea that every quantum event branches the universe, and that observers can only experience branches in which they observe, then this is where the logic leads, not to comforting immortality, not to an afterlife in any religious sense, but to a kind of eternal wandering through the branches of possibility, always surviving, always continuing, always finding yourself in whatever corner of the multiverse still contains a conscious version of you. And suddenly the choices you make today take on a very different significance. Because if you cannot escape continuation, if subjective experience persists in whatever branches allow it, then the question is no longer whether you will live or die. The question is how you will live, which branches of survival you will steer yourself toward, what kind of future you will be the one experiencing whatever comes next. Let me offer an analogy that might help. Imagine you're on a river, a wide river, with countless tributaries splitting off in every direction. Every moment the water divides, flowing down multiple channels at once. You're a single leaf on that water, carried by the current, splitting somehow with each division, becoming many leaves that each continue down their own channel. You cannot stop the splitting. You cannot choose which channels exist. The river will go where the river goes, but you can paddle. You can push yourself towards certain currents, away from others. You can aim for the branches that seem clearer, calmer, more promising. You will never be only one leaf again. You will always be many. But the leaf that experiences this moment, the leaf reading these words, the leaf making choices right now, that leaf has some small influence over which channels it finds itself riding. That is navigational freedom in an Everettian universe. That is what choice means when every possibility is realized. Not the power to create or destroy branches, but the power to steer. The power to influence which branch holds your ongoing thread of experience. And this brings us to something that philosophers have called the practical irrelevance objection. Some critics of many worlds have argued that if every outcome happens, then nothing we do matters, because every action we might take is already being taken by some version of us somewhere. If I am charitable, some version of me is also greedy. If I work hard, some version of me also slacks off. So what is the point of trying to be better? But this objection misses something crucial. It misses the inside view. It misses the fact that you, the specific you, the conscious observer having this experience right now, you only experience one branch, and your choices determine which one. The other versions of you, the ones making different choices, they exist. Yes. They are real. Yes. But they are not you in any experiential sense. They are parallel swimmers, not alternative fates. You cannot trade places with them. You cannot know what they know. You cannot feel what they feel. From your perspective, from the only perspective you will ever have access to, your choices are still yours. Your branch is still your branch. And steering it well is the only thing you can do. Think of it this way. Imagine there are 1,000 people in 1,000 rooms, all facing the same decision. Some will choose well, some will choose poorly. The fact that both outcomes are represented somewhere does not make the choice meaningless for any individual person. Each person in each room still faces their own decision, still experiences their own consequences, still lives their own life. The many worlds interpretation is like learning that those 1,000 rooms are all aspects of a single quantum system, all part of a unified branching structure. But learning that does not change what it is like to be in one of the rooms. It does not change the fact that you have to make a choice and live with the results. The multiverse does not abolish ethics. It does not abolish meaning. If anything, it extends them. Because now the web of consequence is infinite. Now every choice ripples not just forward in time, but outward across branches. Now the self you're shaping is not a single thread, but a vast pattern, a chorus, a constellation of possible futures all rooted in the decisions you make now. Let me try once more to give you a feel for that. Picture your life as a tree. Not a family tree, not a tree of biological descent, but a tree of possibility. The trunk is your birth. The roots go back further, to your parents, to their choices, to the quantum events that brought them together, but leave those aside for now. Focus on the trunk. Focus on the moment you began. From that trunk, branches emerge. Every moment, every decision, every quantum event in every particle of your body, new branches split off. The tree grows not just upward, but outward, exploding in complexity, generating more branches with every passing second. Most of those branches you will never see. Most of those branches contain versions of you who made different choices, who experienced different things, who became different people. But they are all part of the tree, all rooted in the same trunk, all connected in some deep structural sense that transcends any single branch's perspective. Now look at where you are. Look at the branch you're sitting on right now, in this moment, reading these words. Behind you, a vast tangle of possibilities, all the branches that led here, all the decisions and accidents and quantum fluctuations that shaped your path. Ahead of you, another explosion of possibility, all the branches that will sprout from this moment forward. And you, the you that experiences, the you that chooses, the you that navigates, you are always at the growing tip, always at the leading edge of the branch, always facing a future that has not yet branched, always making choices that will determine which branch you find yourself on next. You cannot see the tree from the outside. You cannot grasp its full structure. You are embedded in it, limited to your own branch's perspective, unable to step back and view the whole. But you know it is there. You know if the physics is right, that every possibility is unfolding somewhere, that every choice leads to every consequence, that the tree is always growing, always branching, always generating more versions of you to experience more corners of what is possible, and somehow that knowledge changes things. Somehow knowing that you're not alone, that every version of you is out there, swimming in their own currents, making their own choices, experiencing their own lives, somehow that is both deeply strange and strangely comforting. You're not a single fragile thread that will someday snap. You're a pattern that will never fully end, a structure that persists across the branching, a self that cannot be fully destroyed because it was never fully contained in any single branch to begin with. Now I want to step back from the philosophy for a moment and return to the physics, because I have been speaking loosely about branching and consciousness and observation, and I want to make sure we are on solid ground before going further. The many worlds interpretation, as formulated by Everett and developed by his successors, does not actually say anything about consciousness. It is a mathematical formalism, a way of interpreting the equations of quantum mechanics. What it says is this: the wave function of the universe evolves deterministically according to the Schrödinger equation, and what we perceive as wave function collapse is actually the entanglement of different branches that can no longer interfere with each other. Conscious observers appear in many branches, each experiencing what looks like a single definite outcome. But from the God's eye view of the universal wave function, all outcomes are present simultaneously. This is physics, this is mathematics. This is a statement about the fundamental nature of reality. The connection to consciousness, the arguments about quantum immortality, the philosophical implications we have been exploring, those are interpretations of the interpretation. They are what happens when you take the physics seriously and ask what it means for creatures like us, creatures who experience, creatures who wonder about death, creatures who cannot help caring about the future, even if every future is realized somewhere. And those interpretations are contested. Some physicists think the many worlds interpretation is obviously correct, the only honest reading of the equations. Others think it is extravagant metaphysics, multiplying universes beyond necessity. Some philosophers think the quantum suicide argument is a valid inference from the premises. Others think it contains subtle errors, hidden assumptions, failures of reasoning that undermine the whole structure. I am not asking you to take sides. I am not asking you to believe any particular view. I am asking you to follow the logic, to see where it leads, to feel the weight of the implications, even if you remain skeptical of the premises. Because whatever you believe about the many worlds interpretation, whatever you believe about consciousness and its relationship to physics, the questions raised here are real questions. The puzzles are real puzzles. The strangeness is not going to go away just because we're not sure which interpretation is correct. And now let me tell you about someone who took these questions very seriously indeed. Someone who tried to confront the quantum suicide argument not as abstract philosophy, but as a personal challenge, a question about his own existence, a puzzle that kept him up at night. His name is Max Tegmark, and we have mentioned him before, but there is more to his story, more to his struggle with these ideas, more to his attempt to reconcile the terrifying implications of quantum mechanics with the ordinary business of living a human life. Max Tegmark is a Swedish-American physicist at MIT, a cosmologist who studies the large-scale structure of the universe, the mathematical nature of reality, and the future of artificial intelligence. He is brilliant, creative, prolific. He has published papers on everything from the cosmic microwave background to the relationship between consciousness and integrated information theory. But among physicists who think seriously about quantum foundations, he is perhaps best known for something he wrote in 1998, a paper that laid out the quantum suicide argument in stark, formal terms, and asked what it would actually mean if the many worlds interpretation were true. The paper is called The Interpretation of Quantum Mechanics, Many Worlds, or Many Words, and in it, Tegmark confronts the quantum suicide thought experiment directly. He walks through the logic, he acknowledges the conclusion, and then he does something that few physicists do when faced with uncomfortable implications of their theories. He takes it seriously, not as a call to action, not as something to try, but as a genuine puzzle about the nature of experience and existence. He recognizes that if the many worlds interpretation is correct, then something deeply strange follows about the relationship between consciousness and death. And rather than dismissing that strangeness, rather than retreating to the comfortable position that these are just idle speculations with no real significance, he sits with the discomfort. He follows the logic where it leads. In interviews and lectures over the years since that paper, Tegmark has spoken about what it was like to really confront the implications of quantum immortality. He has described lying awake at night, turning the argument over in his mind, trying to find the flaw, the hidden assumption, the escape hatch that would let him dismiss it. And he has admitted that he never quite found one. Not a definitive refutation anyway. Not something that would let him say with confidence that the argument is simply wrong. What he found instead was something more nuanced. He found that the argument depends on assumptions about consciousness, about identity, about what it means for a particular observer to persist through time that are themselves deeply uncertain. The physics of many worlds may be solid, or at least as solid as any interpretation of quantum mechanics can be, but the bridge from physics to personal experience crosses territory that no one fully understands, and in that uncertainty there is room for doubt, room for the possibility that the argument fails somewhere in the gap between wave functions and subjective experience. But room for doubt is not the same as refutation. And Tegmark has been honest about that too. He has said that the quantum suicide argument haunts him, that it is one of those ideas that changes how you look at the world even if you're not sure whether to believe it. Because once you have seen the logic, once you have followed the chain of inference from the Schrödinger equation to the subjective experience of survival, you cannot fully unsee it. It is there, in the back of your mind, colouring how you think about risk and mortality, and what it means to be a temporary pattern in an infinite branching structure. And here is something else Tegmark has pointed out, something that adds another layer to the puzzle. Even if quantum immortality is true in some strict technical sense, even if some version of you always survives every potentially fatal event, that does not mean your experience will be pleasant. Remember what we said earlier about the quantum gun experiment. If you survive the first trial, and the second and the third, each survival is improbable from a third-person perspective. If you survive 1,000 trials, you are an extreme statistical outlier. You exist in the branches where extremely unlikely things kept happening. Now extend that logic beyond the artificial setup of the gun and the radioactive atom. Extend it to your actual life, to the countless ways you could die at any moment. Car accidents, heart attacks, strokes, falling objects, rare diseases, cosmic rays causing fatal cancers. If quantum mechanics is constantly branching the universe and you are following the subjective thread of survival, then you're not just surviving, you're becoming increasingly improbable. You're drifting further and further into the tail of the distribution, into branches where stranger and stranger things had to happen to keep you alive. Tegmark has speculated about what this might mean. If you cannot die but you can approach death arbitrarily closely, what happens as you age? What happens as your body fails? In most branches, you die. But in some branches, something unlikely happens. An experimental treatment works, a spontaneous remission occurs, some improbable sequence of events keeps you going a little longer. And if you're always on the subjective path of survival, then you experience that sequence, no matter how unlikely it is. This leads to a disturbing possibility that Tegmark himself has noted. Quantum immortality, if true, does not promise you a good existence. It promises only that you will not experience the moment of final cessation. But between here and there, between your current state and that infinitely receding horizon of potential endings, there may be corridors of extraordinary suffering. There may be branches where you survive in states of severe degradation, severe illness, severe pain. Branches where you wish you could die but cannot quite manage it, because in the branches where you do manage it, there is no one left to experience the release. This is not a pleasant thought. It is not a comforting vision of immortality. It is, if anything, more terrifying than simple mortality. At least with ordinary death there is an end. The suffering is bounded. The degradation has a terminus. But if the subjective thread never breaks, if the quantum path keeps finding its way through the maze of possibility, then there is no guaranteed end to anything. Only change. Only the endless rearrangement of what it feels like to be you. I want to be careful here. I want to be honest about what we know and what we do not know. This vision of quantum immortality as a potential nightmare is itself speculative. It depends on assumptions about consciousness and branching and personal identity that may not hold. It depends on the many worlds interpretation being correct. It depends on the quantum suicide argument being valid. And all of those dependencies are uncertain, but the uncertainty cuts both ways. Just as we cannot be sure the argument succeeds, we cannot be sure it fails. Just as we cannot be confident that quantum immortality is real, we cannot be confident that it is not. We are left in a strange epistemic position, unable to dismiss these ideas but unable to fully embrace them, haunted by possibilities we cannot verify and cannot refute, and maybe that is where we have to leave it. Maybe the honest conclusion is not a conclusion at all, but an acknowledgement of irreducible uncertainty. We have followed the thread from Schrödinger's cat through Everett's interpretation, from quantum decoherence through the thought experiment with the gun, from the mathematics of branching through the philosophy of personal identity. We have seen what the arguments claim and where they might fail. We have encountered the vision of the great cosmic tree, endlessly growing, endlessly generating versions of every possible outcome. And we have asked what it means for creatures like us, creatures who live and die, creatures who care about the future, creatures who cannot help wanting to know what happens next. The answer, as best as I can give it, is that we do not know. We cannot know, not with the tools we currently have. Quantum mechanics tells us extraordinary things about the nature of reality, but it does not tell us what happens to subjective experience when the wave function branches. The mathematics is silent on that question. The experiments cannot speak to it. We are left with inference, with philosophy, with the uncomfortable feeling that something important is happening, but we cannot quite see what it is. And yet, there is something to be gained from having made this journey. Something changes when you sit with these ideas long enough. Not certainty. Certainty never arrives. But something else. A shift in perspective. A loosening of assumptions you did not know you were making. A recognition that the world is stranger than it appears, that the relationship between physics and experience is deeper and more mysterious than our everyday intuition suggest. Let me tell you about another physicist who grappled with these questions. His name was John Archibald Wheeler, and he was one of the great figures of 20th century physics. He coined the term black hole. He was Richard Feynman's doctoral advisor. He worked on the Manhattan Project. He was, in every sense, an insider, a builder of the theoretical framework that gave us quantum mechanics and general relativity as we know them today. And late in his life, Wheeler became increasingly interested in the question of observation, in the role of conscious beings in bringing reality into focus. He developed what he called the participatory universe hypothesis, the idea that observers are not passive witnesses to a pre-existing reality, but active participants in the ongoing creation of what exists. This is not the same as the many worlds interpretation. In some ways, it is almost the opposite. Wheeler suspected that the universe requires consciousness to exist, that the act of observation is constitutive of reality rather than merely revelatory of it. But what Wheeler and Everett shared, despite their different conclusions, was a willingness to take the strange implications of quantum mechanics seriously, a refusal to retreat to the comfortable position that these are just mathematical formalities with no deeper meaning, a recognition that when your best physical theories say something profoundly weird about the nature of reality, you do not get to ignore that weirdness just because it makes you uncomfortable. Wheeler once said something that has stayed with me ever since I first read it. He said, "We live on an island of knowledge surrounded by a sea of ignorance. As our island of knowledge grows, so does the shore of our ignorance." That is where we are now, on the shore, looking out at the sea. The many worlds interpretation, if it is correct, implies a vast ocean of existence that we can never directly access. Branches beyond branches beyond branches, each one as real as this one, each one containing versions of you and me, and everyone we have ever known or loved or feared. A sea so vast that our island of experience is less than a drop within it. And somewhere in that sea, if the arguments are correct, there are versions of you who are still alive. Versions who survived things that killed you in this branch. Versions who took different paths, made different choices, encountered different fates. Versions who are asking the same questions you are asking now, wondering about consciousness and death, and what happens when the wave function branches. Some of those versions have it better than you do. They made choices that worked out, avoided dangers that found you, discovered paths that you missed. Some of them have it worse. They are suffering in ways you cannot imagine, trapped in branches where terrible things happened, following the thread of survival through landscapes of extraordinary difficulty. And all of them are you. All of them share your past up to some branching point, diverging only when quantum events sent you down different paths. The pattern that is you is not a single line but a tree, spreading through the space of possibilities, encompassing more than any single branch could contain. Stop and feel the weight of that for a moment. You are not alone. You have never been alone. Every version of you is out there somewhere, experiencing their own life, wondering about the others, held together by the fact that they all grew from the same root, even as they grew toward different skies. And when this version of you dies, when the body you currently inhabit stops functioning, when the brain that generates your current experience stops generating anything at all, the pattern does not end. It continues in the branches where you survived. It continues in the versions of you who are still asking questions, still wondering, still experiencing the strange gift of consciousness. Whether that is immortality depends on what you mean by immortality. Whether that is comfort depends on what you need from comfort. Whether that is true depends on questions we cannot currently answer about quantum mechanics and consciousness and the nature of personal identity. But it is not nothing. It is a possibility. A genuine possibility grounded in our best physical theories taken seriously by serious physicists. Not a fantasy or a wish, but a potential description of how things actually are. And now I want to take you somewhere else. Away from the physics and the philosophy. Away from the thought experiments and the wave functions. I want to take you somewhere quiet. Somewhere final. Somewhere you have been avoiding since the beginning of this journey. I want to take you to your own death. Not to frighten you, not to unsettle you. But because that is where all of this leads. That is where it has always been leading. From the first moment I asked you to picture the cat in the box, from the first moment I told you about the branching of the wave function, we have been circling around this point like a spiral narrowing toward its centre. You're going to die. In this branch, in this version of the story, your heart is going to stop. Your brain is going to cease its electrical dance. The pattern that calls itself you is going to dissolve into something else, something that does not ask questions or wonder about the future or care what happens next. And that is going to feel like something, or rather, it is going to feel like the end of feeling. The stopping of a process that has been running for your entire life. The moment when subjective experience, whatever it is and wherever it comes from, does whatever it does when its physical substrate fails. Except, and this is the strange part, the part that has been haunting us this whole time, if the many worlds interpretation is correct, that is not the end of the story. It is only the end of one branch. In other branches, something different happens. In other branches, you survive. In some branches, the survival is dramatic, a near miss, a medical miracle, an intervention that seemed impossible. In other branches, the survival is mundane. The danger simply never arose, the disease never developed, the accident never occurred. And here is the question that no one can answer. The question that keeps Tegmark up at night. The question that has been running beneath everything we have discussed for the past 2 hours. Where are you? Not your body, not the atoms that make up your brain, but you, the experiencing thing, the consciousness, the pattern that asks questions and wonders about death and cannot help caring about the future, even if every future is realized somewhere. Are you the thing that ends in this branch? Or are you the thing that continues in the branches where you survive? Or are you somehow both, your identity spread across the tree like roots spreading through soil, present in every branch but identical with none? The question sounds metaphysical. It sounds like the kind of thing philosophers argue about in seminar rooms, while the real world goes on ignoring them. But it is not metaphysical. It is about physics. It is about what kind of thing you are and what happens to that thing when certain physical events occur. And physics, at the moment, does not have an answer. Quantum mechanics does not tell us what consciousness is. It does not tell us how subjective experience arises from physical processes. It does not tell us whether the pattern that is you persists across branching events, or whether something breaks when the wave function diverges. These are gaps in our knowledge, and until we fill them, the quantum suicide argument remains unresolved. Not proven, not disproven, suspended between possibility and refutation like the cat between life and death. And maybe that is the final lesson. Maybe the point of all this is not to give you an answer, but to reveal the question, to make you see, really see, that the relationship between consciousness and physical reality is stranger and more uncertain than you thought, that your intuitions about death and continuity and personal identity are not as solid as they feel, that the deepest questions about what you are and what happens to you are genuinely open, genuinely contested, genuinely undecided. We live in a universe described by quantum mechanics. That is not speculation. That is established science, confirmed by countless experiments, encoded in the technology you're using right now to read or hear these words. And quantum mechanics says something strange about reality. The exact nature of that strangeness is disputed. Many worlds, Copenhagen, pilot waves, spontaneous collapse, each interpretation telling a different story about what the equations mean. But the strangeness itself is not disputed. It is written into the mathematics. It shows up in the data. It is a feature of the deepest layer of reality we have yet discovered, and you are part of that reality. You're not separate from it. You're not a classical observer looking in from outside. You're a quantum system, made of quantum parts subject to quantum rules. Whatever those rules really mean, whatever they really imply about observation and consciousness, and the branching of the wave function, those implications apply to you. You're inside the cat box, even if you do not feel the walls. So here is where I leave you. Not with an answer, but with a question. Not with certainty, but with wonder. Not with the end of the story, but with the recognition that stories about the nature of reality never really end. They only deepen, only branch, only open onto further questions that retreat as we approach them. Tomorrow you will wake up and live your life. You will make decisions, encounter risks, navigate a world full of dangers you have learned to ignore. And most of the time, you will not think about quantum mechanics or branching universes or the subjective thread of survival. You will live as if this branch is the only branch, as if your story has one author and one reader and one ending waiting somewhere in the future. That is fine. That is how humans live. We cannot hold the strangeness in our minds all the time. We have to function, have to plan, have to act as if the world is simpler than it is. But sometimes, late at night, when the world is quiet and your thoughts drift toward the edges of what you know, you might remember what we have discussed here. You might feel, just for a moment, the vastness of the tree, the infinite branching, the countless versions of you swimming in their own currents. And you might wonder which branch you are on, which version of the story you are living, what happens to the pattern when this particular telling reaches its end. And in that wondering, you will be doing something important. You will be confronting the unknown. You will be sitting with the uncertainty. You will be asking the questions that science has opened but cannot yet close. The many worlds interpretation may be true, or it may be false. The quantum suicide argument may be valid, or it may contain a fatal flaw we have not yet identified. Consciousness may persist across branching events, or it may not. We do not know. Perhaps we cannot know, not with the methods we have, not with the minds we are. But we can wonder. We can follow the logic. We can take the strangeness seriously. And we can recognize that whatever the truth turns out to be, whatever the correct interpretation of quantum mechanics implies about consciousness and death and personal identity, it is almost certainly stranger than our everyday intuition suggests. The universe is not a machine for confirming our expectations. It is a place of genuine mystery, genuine uncertainty, genuine possibilities that exceed our imagination. You came here wondering what quantum mechanics says about death. What I hope you leave with is something broader and deeper, an appreciation for how little we know, how much remains to be discovered, how open the future is in ways that physics itself cannot close. The tree is still growing, the branches are still spreading. Somewhere out there, a version of you is already dead, and somewhere else, a version of you survives, changed perhaps, degraded perhaps, or perhaps flourishing in ways you cannot predict. And here, now, in this branch, you are still asking questions, you are still wondering, you are still part of the great pattern, the endlessly branching wave function, the cosmic experiment that began long before you were born and will continue long after every version of you has run its course. That is where we are. That is what we know. That is what remains uncertain. The Schrödinger equation keeps evolving. The branches keep multiplying. And somewhere in the infinite tree, the pattern that is you keeps asking what it means to be a temporary thing in an eternal structure, a conscious moment in unconscious vastness, a question that the universe poses to itself without ever quite arriving at an answer. Thank you for making this journey with me. Thank you for sitting with the strangeness. Thank you for following the thread into the dark. whatever happens next, in this branch, in the others, in all the futures that quantum mechanics may or may not hold, I hope you carry something of this wonder with you. I hope you remember from time to time that reality is stranger than it appears, that consciousness is more mysterious than it feels, that the relationship between the observer and the observed runs deeper than our intuition suggests. The cat is in the box, the atom is in superposition, and you are here, now, in this moment, wondering what happens when you finally open the lid. Settle in. Let the question stay open. The answer, if there is one, can wait until morning.